Polarity and intermolecular forces.
By Aaron&Andrew 2. So, before we can understand IMF or intermolecular forces, we must first understand polarity. So what is polarity? Polarity is the separation of an electric charge leading to a molecule having a dipole moment. Well, we know that molecules are made of atoms, and that these atoms contain electrons, protons, and neutrons. The protons are positive, the electrons are negative, and the neutrons are, well, neutral. We also know that opposite charges attract. For example, positive protons will attract negative electrons and balance out. Well, in molecules, it's these attractions that create polarity. Take, for example, water. Water's molecular formula is H2O, or 2 hydrogen atoms and an oxygen. Oxygen has 8 protons, and therefore is more electronegative than the hydrogen, who has 1. When they come together and bond, oxygen becomes greedy, and with its greater electronegativity, causes stronger attraction, and therefore pulls electrons closer to itself and away from the hydrogen atoms. This causes the oxygen to become more negative than usual, and the hydrogen more positive. This is known as a dipole moment, and serves as the basis of polarity. A dipole moment is when a molecule has a partial positive and negative charge at its poles. So how do we figure out whether a molecule is polar or not? Well, it turns out we need to use several other key concepts we've already learned about. These are Lewis structures, molecular geometry, and electronegativity rules. Using what we know about Lewis structures and molecular geometry, draw out the molecule. Once the molecule is drawn out, draw arrows pointing towards the more electronegative atom. These are the dipole moments that are occurring. Cancel out any charges that point towards one another. The remaining arrows point to the more negative side. This means that the molecule is polar. So if there are any arrows left, the molecule is nonpolar. Great! So now we understand polarity. How does it relate to IMF, or intermolecular forces? Well, molecules, like atoms, interact with one another on a much larger scale. Intermolecular forces are the bonds that hold the molecules together to form that thing. There are several forms of intermolecular forces with varying strengths. The strongest type is ionic dipole. This is between an ion, such as sodium plus 1, and a polar molecule, like water. This is a special dipole-dipole interaction between the hydrogen atom and a polar NH, OH, or FH bond, and an electronegative O, N, or F atom. After that comes dipole-dipole. This is when two polar molecules are attracted to each other. Then comes dipole-induced dipole. This is weak, where a polar molecule induces or makes a normally nonpolar molecule to act polar to the time it is around the polar molecule. Once it is away from this polar molecule, the nonpolar molecule returns back to acting nonpolar. Finally comes induced dipole-induced dipole. Induced dipole to induced dipole is the weakest type of IMF. This is where two nonpolar molecules make each other act polar while they are around each other. But when they are away from each other, they act nonpolar. Intermolecular forces also amount for many special properties between molecules. The first is surface tension. This is the amount of energy needed to stretch or increase the surface of a liquid. The higher intermolecular force, that means a higher, stronger surface tension. The next property is cohesion. This is where the intermolecular forces between a molecule makes the molecule attract to itself over others. Another intermolecular force is adhesion. This is pretty much the opposite of cohesion, where the intermolecular force makes one molecule attracted more to another molecule more than other molecules of itself. Another IMF property is viscosity. This is a fluid's resistance to flow. For example, ketchup, which is very viscous, has a higher IMF than alcohol, which is not viscous and flows very well. Stronger IMF means stronger viscosity. The next property is boiling point or melting point. This property is influenced by IMF because in order to melt or boil a molecule, you're going to need to break the intermolecular bonds between those molecules. A stronger intermolecular force means higher temperatures needed to melt or boil, and a weaker intermolecular force results in lower temperatures to melt or boil these molecules. I hope you enjoyed our presentation and have a nice day.